A ball is launched straight towards the ground from a height h. When it bounces off the ground, it loses half of its kinetic energy. It reaches a maximum height of 2h before falling back to the ground again. What was the initial speed of the ball? So we can use some energy equations to solve this first. So first let's write out the initial energy. Like this is going to be the initial energy right when it's launched. So the initial energy is going to be equal to the initial kinetic energy of the ball plus the initial potential energy it has. So the initial kinetic energy is given by the equation 1/2 times the mass times the initial velocity squared. And we're trying to find what this initial velocity was of the ball. And we are just going to assign it a mass m, and it's not really going to matter. And of course, the gravitational potential energy is given by the mass times the gravitational acceleration times the height h. Now, I'm going to also write out its final energy. So this is going to be right like at this point when it reaches the maximum height of 2h. So this is going to be equal to the final kinetic energy plus the final gravitational potential energy. So the final kinetic energy is going to be 0 since it's at the maximum height and it's about to fall back to the ground again. However, the potential energy is going to be the mass times the gravitational acceleration times the height, which is 2h. So this is just simply 2mgh. And now we need to find some way to relate these two. So I'm going to draw two diagrams, and let's say this is the ball right before the bounce. So this is right before bounce. And this is going to be the ball right after the bounce. So let's say that this is after the bounce. And let's say that has an initial kinetic energy, KIB, or the kinetic energy before the bounce. And after the bounce, it has a final kinetic energy. And I'm going to use the B subscript to differentiate these two, because these two aren't the same. This is the kinetic energy right after the bounce, and this is the kinetic energy at the final position. While this is the initial kinetic energy of it being launched, and this is the kinetic energy right before contact. So it says once it bounces off the ground, it loses half of its kinetic energy. So the initial kinetic energy before the bounce is going to be 2 times the final kinetic energy after the bounce. And we can expand the initial kinetic energy right before the bounce. That's simply going to be equal to the initial energy, as all of the gravitational potential energy it has gets converted to kinetic energy right before it hits the ground. So that's going to be the sum of the initial kinetic energy of the launch plus the gravitational potential energy that it had. And the final kinetic energy after the bounce, that's just simply going to be equal to 2mgh. Since right after the bounce, its kinetic energy is going to be converting to gravitational potential energy, and it's going to keep going until all of the kinetic energy gets converted to gravitational potential energy. So these two are actually equal. So the final energy at height 2h is actually equal to the initial kinetic energy right after the bounce. So I'm going to make a little more room by erasing these. So now we have this. So the final kinetic energy right after the bounce is equal to 1/2 of the initial kinetic energy right before the bounce. So that's going to be 1/2 of 1/2 mv squared plus mgh. That's just this expression that we found here. And this is going to be equal to 2 mgh. That's also what we found earlier. So, and now we have to solve for the initial velocity. So we can solve this equation here. So this becomes 1/2. Oh yeah, all of the masses cancel out since they don't really matter anymore. You can divide everything by the mass and that won't matter at all. So 1/2 of the initial velocity squared plus mgh, or sorry, the m got cancelled, so just gh, is equal to 2gh. So then the initial velocity squared is equal to gh. So then the 1/2 of the initial velocity, so the initial velocity squared is going to be this is going to be equal to 2gh. Oh wait, sorry. I forgot to multiply this to the other side first. So this is actually going to be 4gh, and this is going to be 3gh. So this, the final velocity squared, is actually going to be 6gh. So that was a little mistake there. And so now we can solve for the final velocity. The initial velocity. And the initial velocity is going to be equal to the square root. The initial velocity is going to be the square root of 6gh. So that's the initial launch speed of the ball. And that is how you would solve this problem here.